All right, we're going to work on a few things here. We have multiple ideas today, so we're going to try and break it into each one. First thing is, hopefully, something that's super duper old, counting method. This means that if you have so many ways to make a selection and then so many ways to make a second selection, we just simply multiply them together to find out how many different choices you really have. So quick and dirty, 5 shirts, 8 pair of pants, 5 times 8, you're 40. Done. Okay, so my answer machine allows you to call home and get messages by entering a 3-digit code. So 1, 2, 3. Now the thing to remember is that 0 through 9 is 10 options. So if you want to call my house and break into my answer machine, that doesn't exist anymore. That's how old this problem is. But you get the idea. We could translate this into cell phones right now. 10 times 10 times 10. Okay, so you would have 1,000 different codes to work through, because I could repeat those items. All right, so what you probably saw in middle school, a couple of these problems. All right, so we're going to go on vacation. The Murray family's going. They can choose a trip to the beach or to the mountains, so that's 2. They can choose their transportation to get there, a car, plane, or a train, that's 3. And how many different ways can they select a destination followed by the means of transportation? That's 6. They don't have too many choices to make, not a big deal. But hey, maybe when they get there, they're hungry for a sandwich, right? So here's what they can get. They can get white wheat or rye bread, that's 3. They can then choose butter, mustard, or mayonnaise, that's 3. How many different combinations of bread and spread are possible? 9. So they actually have more choices for this generic sandwich than they do for how they're going to get there. All right, these are kind of the middle school idea, just getting you into that very, very basic idea. Here's the next level that I'd like to talk to you about. All right, you guys have probably seen this somewhere around if you're watching this from Pennsylvania. All right, so we have 7 blanks. 1, 2, 3, 4, 5, 6, 7. And this alludes to what we talked about before. If the first 3 digits, or first 3 items happen to be letters, remember there's 26 letters in the alphabet, and the next 3, the next 4 are all numbers, that means we're doing 10 times 10 times 10 times 10, right? I'm not saying that I'm going to put 10 in there, because I can't put 10 as 2 digits in that spot. These are the number of choices I have. So this is really taking that idea of multiplying your choices until we get a final answer. Now this was an upgrade that we went to. On the right here, I have the license plate in Pennsylvania. You got a friend in Pennsylvania. It sounds really nice, right? Hey, we're friends here. But notice the big difference is we're short one of the letters. So we would take, or one of the numbers on the end. So we'd take our 26 times 26 times 26 times 10 times 10 times 10. So we know that we have a multiplier of 10 on the new one that we did not have on the old one. Now, I'll also tell you that this transition got us a bunch more license plate, but start thinking about what we could do next. We don't want to join, we don't want to put any more characters on the license plate. So what could we flip-flop? So what I envision in the future is we're going to take one of these and we're going to change it out to a letter. So we take one of these and make it into a letter, and that starts to present a lot more options when we look at multiplying these. All right? But just something to lay out there. Hey, fun fact, currently with the 7 characters on our license plate, we are tied with California and Texas. That's the most you'll see in any of the continental United States. Way to go, Pennsylvania. We're populated. All right, so that's the very first thing today. The second thing is we're going to deal with 2 things. One is called a permutation. Okay, when you think about the permutation, I always start drawing rings. All right, we didn't see it. Well, we won't see it this summer because I'm thinking about the Olympics. Because what happens in the Olympics, things come in first place, second place, third place. That means the order matters. And if you don't think the order matters, then go ahead and, ask somebody that was training for the Olympics. The order matters to them. Okay, so its permutation is an arrangement of items in which the order matters. Okay, so you're going to put something first, you're going to put something second, you're going to put something third. I'm not just going to pick a group of athletes and say they're the Olympics. No, that's not how it works. Next thing you're going to see is some fancy formulas for this. You don't need it because your calculator has what's called a factorial button on it. And the same place we find that, you're also going to find a capital P like this for permutation. So we're going to show you how that works on the calculator. But our focus right now is just what's the difference. So this is where the order matters. The second concept is just called a combination. So a combination means that you had 5 of something and you just want to pick 2 of them. And it really doesn't matter and the order doesn't matter. Okay, so if you're just picking 2 of something, then that's how it works. In a permutation, we'd say 5, and we want the first and second place. So how many ways could this happen? All right, so we're going to focus on the calculator next and show you how that works. So we're going to start with the number that we're starting with. Okay, and everything we're going to work with happens to be in math, but it's under probability. Notice I'm going to go left to get there. That makes it a little bit faster. So a few things that we have is our permutation. So notice I put the permutation in there. I have to tell it 2, okay, because it was 5, choose 2, and that means we're going to get 20. So what if the order doesn't matter? I just need to pick 2, right? You know what? Hey guys, there's 5 people in class today. I really need 2 of you to get down to the office. We got some new books. And could you grab those and bring them up here? That'd be great. Okay. So notice we actually cut the choices in half because the order didn't matter anymore. Okay, so that's our big difference. The other thing you saw in that formula was factorial, and notice it was also listed in there. So this was math. Again, I keep going back through here. I'm trying to get the probability. I'm going to get down to number 4 and factorial. I want to make sure you get a chance to see this as we get into it in Algebra 2 next year. You'll see for factorial that means 5 times 4 times 3 times 2 times 1. It's that number and multiplied by all the numbers underneath it. And it does get used within the formula, but we're not going to use those formulas because our focus today is understanding the difference between permutations and combinations so you're ready to roll when we have to deal with the rest of it. Okay, so Olympics, first, second, third, that's a permutation if I'm just picking something. All right, so let's get to some of these. 8 people enter the contest. 8, okay. The best pie contest, that sounds good. How many ways can blue, red, and green ribbons be awarded? Now keep in mind, blue ribbon means first place, red ribbon means second, and green means third. So in this case, the order matters, which means it should be a permutation. Okay, they're going to award the top 3. So it's 8 permutation of 3. You can go back to those calculator steps to get a number then. 5 cousins at a family reunion decided that 3 of them will go to pick up a pizza. It must be a big pizza. There are 5 people there, 3 of them are going to go. How many ways can they choose the 3 people to go? Now, are they putting them in order, or are they just choosing 3 people? They're just choosing 3 people, so it is a combination. Again, review the prior video portion for calculator work if you need to. All right, from a group of 9 different books, 5 books are to be selected and arranged on a shelf. How many arrangements are possible? Okay, so we have 9 books. We're going to select 5 of them. Does the order matter? Absolutely, because we're talking about an arrangement. So the order in which we put them up there is going to be important to us. That makes it a permutation. Now, how many different orders can 10 dogs be lined up to be groomed? So you have 10 dogs. We're going to line up all 10 of them. Now we're selecting all of them, so it wouldn't make sense to make this into a combination. So it is a permutation. So we have dog 1, dog 2, dog 3, dog 4, dog 5, dog 6. You get the idea. The order does matter, because if we flip 1 and 2, that changes the order in which they will be groomed. So it's permutation. All right. So hopefully you're getting some of this vocab as we kind of work through here. Suppose you want to arrange 6 trophies on a shelf, selecting from the 15 in your collection. So 15, you're going to choose 6 of them. And what are you going to do with them? You're going to arrange them. Well, if the order matters, what's it going to be? Very good. It's permutation. Now we're starting to get the hang of this. All right. A group of 7 students working on a project needs to choose 2. So 7, and they're going to choose 2 to present the group's report to the class. How many ways can they choose the 2 students? Are they picking the first place person and second place person? No, they're just a group of students working on things, so it must be a combination. And our emphasis here is not about the number to get afterwards. You can always go back to the beginning of the video to find that. There are 10 finalists in the figure skating competition. How many ways can gold, silver, bronze? That's first, second, and third. Remember, that was our idea in the beginning. So if you're going to give out some placements, that must be a permutation. All right, here's where we'd like you to give you an example of permutation in life. So give me something in which the order matters. And then a combination. Give me something where we just pick something. All right. In this section, we're just going to run through these again and again, and we're just going to say permutation or combination. So super value lunch and deep fried Dan's, probably delicious food, not very good for us. We're going to choose 3 things. We're going to choose 3 things. Okay, so that must be a combination, right? I don't have to order them first, second, and third. I'm just picking them. 9 people are running for president and vice president. Now, in this situation, we're going to assume this is first and second. And now that I put that caveat on there, we know that this should be a permutation. Out of 100 people, the first 5 show up at the radio station, get tickets to see AC/DC. All right, that's a really old rock band, right? Okay. So the first 5. Now, being in the first 5 is important, but person number 1 and person number 4 get the same thing. So that makes this a combination. So you can see how this is starting to get a little bit tricky, but I'm trying to make sure I clarify what's going on. So sometimes we can take either one. No. In very rare occurrences, we could take either one based on the way you thought the problem was. So always explain your thinking if you're not sure. 12 people are competing for gold, silver, and bronze. Do I need to say any more? Well, I mean, it is a burping competition, but you get the idea. Gold, silver, bronze, I don't even care what the competition is. It's a permutation. How many different ways can 5 people stand for a photo? Okay. Now, this means that we're trying to put them in different places, right? Different ways. So that must be permutation. This is a lot like the dogs lining up to be groomed. All right. So next, how many different batting orders? Now, you have to understand that batter number 1 has to be batter number 1 the whole game. Those things don't change. So that means the order matters. So that means this must be a permutation. If we're solving the whole thing, 9, permutation of 9, because we do have 9 players. A band has 7 new songs, wants to put 5 of them on a demo CD. How many arrangements of the songs, 5 songs, are possible? So here we're going to start getting into some keys. Not only are we going to pick 5 of the 7, we want to arrange them. So the first song, right? Should that be the best song? So it's 7. Ooh, why did I write that? This has an arrangement, so it's permutation of 5. All right, 20 people report for jury duty. Civic duty right there. How many different 12-person juries can be chosen? So we're just going to pick 12. We're not picking them based on the greatest one, because what makes a great juror? I don't know. All right, so that makes it a combination, right? We're just picking 12. Doesn't matter if you're person number 1, 2, 3, 4, right? You're just a juror, just like the other people that were selected. How many different ways can you choose 3 types of flowers from a selection of 15? Right? So notice we're just going to choose them. So it's 15 combination of 3. That gets us a little bit of our difference here. So hopefully that helped trying to clarify some of those things. We're looking for keywords if we're just choosing something versus making an arrangement of things. There are some other keys that makes this super, super simple. As soon as you see first, second, and third, or gold, silver, bronze, you know it's a permutation. And if you missed the calculator portion, please go back to that so that you know how to find the actual number that goes along with these.